All right, pre-calc students, this is going to be a review of solving systems of equations with a couple of different methods. So first method we're going to review, something you learned in Algebra 1, would be the substitution method. Idea being, as we solve a system of equations, is a solution to a system of equations is going to be an ordered pair, value for x and a value for y, that satisfy both of the equations within the system. So we're trying to look for a pair of values that works in this equation and this equation at the same time. So substitution is one way to find that, and I'll refresh your minds on how that works. So hopefully the video quality works out and you can see this okay on the whiteboard. If I'm going to use the substitution method, I'm going to get one of the variables all by itself. So the variable that sticks out to me is this one. I see a y all by itself. I'm going to do what I can to get it by itself. In this case, for me, I think it'd be easiest to add y to both sides and at the same time subtract the 10 from both sides, which would give me an expression equal to 2x minus 10 is equal to y. Okay? So I've isolated one of the variables and made a single equation with that variable by itself. So y equals 2x minus 10. The substitution part comes when I take this expression, 2x minus 10, and I substitute for y in the other equation. So what I will do then is I'll add the 6x here plus 4 times, instead of y, I'm going to replace or substitute for y. I'm going to replace y with that expression that's equal to y, 2x minus 10. And that equation is equal to 1. So what I've done now is I've created a single equation with a single variable. There's just x's in this equation, and I can solve for x. So I'm going to distribute the 4 of 8x minus 40. I have the 6x here added to that, equals 1. 6x and 8x become 14x. Add the 40 to both sides, I'd get 41 over here. Last step as I solve for x would be to divide by 14. So when I'm all done, x is going to equal 41/14, which I'm pretty sure you can't reduce. Now that's half of the ordered pair that is my answer. So I'm going to start, my ordered pair is 41/14, comma, something. Well, what is that something? Well, to figure out the y value, I'm going to substitute again. But I'm going to take the x value that I know is the answer and substitute it back into this equation that gives me y. So y is equal to 2 times x. Well, x was 41/14 minus 10. Cleaning that up a little bit, well, 2 times 41/14, I could probably cancel 2 and make that a 7. So I get 41/7 minus, I'll change 10 into 70/7 and put those two things together. Y is going to equal negative 29/7. Okay, so that would be the y value of my ordered pair that is my answer. You get 29/7. So this would be the solution to my system of equations. It's okay to have fractions. There's nothing wrong with that. Okay. Now the thing that you can do to check your answer, or sometimes it might be easier to solve a system, would be by graphing. So real quick, if I could pull it up here, if we graph these two expressions. It looks something like this. So again, you have to trust me, maybe the video shows up all right, but if I were to graph them and then click on the intersection, that intersection is at 2.929, comma, negative 4.143. And I bet if you check these fractions and turn them into decimals, those would be the two decimals that you come up with. So that's an example of solving a system of linear equations using substitution.